Hi, I'm Zack from Kid2Kid Tutorials, and today we're going to be talking about SAS similarity. So before we start on SAS similarity, I'm going to explain to you what it is. So SAS similarity is when two sides in one triangle are in the same ratio as two sides in another triangle. So what that means is two sides in one triangle must be equal to two sides in another triangle. And then we have an angle of each triangle that must be equal also. Now let's get to the problem. So now that you know a little bit more about SAS similarity, we can use that to try to prove this problem, that IJ is parallel to GH. So we're asked to prove that IJ, line IJ right here, is parallel to line GH right there. And we're given information such as M is the midpoint of EH and FG. So M is the midpoint of EH and FG here. We're also given that E and F are midpoints of IM and MJ. So let's use that to prove that this is similar by SAS first, and then you can use that to prove this. So we know that M is the midpoint of EH and FG, and E is the midpoint of IM and MJ. F is the midpoint of MJ. So you can use that to say that since M is the midpoint of FG, we know that GM is a common ratio with is equal to FM. And we know that F is the midpoint of JM, so we know that JF or FJ is equal to FM. So using that, we know that JM is a corresponding angle to MG. And similarly here, we know that IM is corresponding angle to MH. So we can write JM divided by MG, JM divided by MG is equal to IM divided by MH, which is equal to 2, because a midpoint shows half of the line, where half of the line is. So if we have F is the midpoint of JM, that means half of the line goes here, and then the other half continues on to whatever that point is. So let's start with an example. Let's say that JM is 4, and there's a midpoint F here. So half of the line would be 2. So FJ would be 2. So 4 divided by 2 is 2. Now with 8, if JM was 8, and half of it would be 4. So 8 divided by 4 is 2. So that's why all of this is equal to 2. Now that we know these two sides are, so JM and MG are corresponding angles, and IM and MH are corresponding angles, we have two sides of each triangle that are equal, but we still have to find the angle. So we know that angle GMH, so angle GMH is equal to angle EMF, because they are vertical angles, and vertical angles are always equal. So we now prove that this is similar by SAS. So now that we've proved these are similar, we can use that to prove that IJ is parallel to GH. So since we know these are similar by SAS, we can say that IJM, angle IJM, is equal to angle MGH. So IJM is equal to MGH. And that says that these lines are parallel. So before we start on the problem, you have to know what SSS similarity is first. So SSS similarity is where each side of one triangle is the same constant multiple of the corresponding side of another triangle. So that means is 3 sides of one triangle, so that's all the sides of one triangle, must be corresponding to all the sides of another triangle. So let's get started on this problem, since you already know the basics of SSS similarity. So we have, given the side lengths shown in the diagram, prove that line AE is parallel to line BC, so line AE is parallel to line BC, and line AB right here is parallel to DE, right there. So let's try to find the common ratio first to show that these are similar by side, similarity. So first we have AB, side AB is corresponding to side DE. So we have AB divided by ED. DE. And then that's equal to line BC divided by line AE. Also, we have line AC divided by line AD. So that's equal to line AC divided by line AD, which is equal to, so let's try to find the common ratio. So we know AB, so we'll do this one since we know all the sides of it. We know that AB is 5 divided by DE, which is 10. So we know the common ratio is 1/2. So AB divided by DE is equal to BC divided by AB, which is equal to AC divided by AD, which is equal to 1/2. So that's the common ratio between all of these, and we know that this triangle ABC is similar to triangle AED by SSS, or side similarity. Now that we know the corresponding sides and the common ratio, which is 1/2, we can use that to prove that line AE is parallel to line BC and line AB is parallel to line DE. So we can prove that line AE is parallel to line BC, given that BAC, this angle right here, so angle A, is equal to EDA, so which is this angle right here. So we can say that because, remember, these are triangle ABC is congruent to triangle AED by SS similarity. So we can say that BAC, angle BAC, is equal to angle EDA. And we can also say that angle ABC, which is this angle right here, is equal to angle DAE, because they're similar by SSS congruence. So that proves, so since angle BAC is equal to angle EDA, that proves that line AE is parallel to the line BC. And since ABC is equal to DAE right here, we know that line AB is parallel to line DE. Thank you for watching Kid2Kid Tutorials. And if you like our videos, please share, like, and subscribe. Thank you.